Hi, in this video I want to go over how we find the mean and standard deviation of group data. So pause this video and go over the problem described here. Then we'll continue. Here I have the data in Excel. Let's understand what these values are in the various columns. It's important that you not just see numbers and then you know what to do with the numbers. These numbers represent something, and you should understand that. The machine will do your calculations for you. You need to understand what calculations you need, and this understanding comes from understanding well what these numbers represent, and what you want to do with them. So here we want to find the mean and the standard deviation. We'll find the variance first of the set of data. Now we don't actually have the original values, we just have this summary here, which is our frequency distribution. So let's take a look and see what we have here. In this column, well, what we have here are the various classes. In this column we have the lower limit, and here we have the upper limit of the classes. What we have here are the frequencies. So this is telling us that we have 14 values between 97.3 and 97.6. We have 32 values between 98.5 and 98.8. So I'm assuming these are Fahrenheit temperatures. Now, how can we find the average of these values if we don't know what the individual values are? Well, we're going to make an approximation. We're going to say that, well, all these 14 values are the same. Now, we know they're not, but we don't have the original values, so we're going to say they're all the same and equal to what? Well, we're going to say they're equal to the midpoint. We are expecting that we won't be off by too much when we finish, because we are expecting the values to be distributed somewhat, maybe not very evenly, but distributed somewhat in each class. Now, if all the values in, let's say, this class are 97.3 and all the values in this class are 97.7, then yes, the error will be great. But that is not what we expect. And it's reasonable to expect that the values will be distributed, that they'll not all be on one side, at least not in every class. Maybe in one class we have the values on one side, but then we expect in some other class the values maybe to be on the other side, So in all, it should even out. So that is why we're going to find the midpoint. We're going to find the midpoint of every class, because we're going to assume, for example, that in every class, all the values are equal to whatever the midpoint is. And remember, this is why what we do is an approximation. We are not getting the exact value of the mean and the standard deviation of the data set, because we don't have the data set. We just have this summary. So our frequency table is a summary of the original data. So how can I find the midpoint of this class? Well, I just need to take the lower limit and add it to the upper limit and divide by 2. So I can just do like this. I'm going to take this lower limit. Oh, before that, we got to put our little equal sign. So let's remember that. And then, so that's the lower limit plus the upper limit, and then divide that by 2. And we have that value. And then we just drag down. A faster way is to just double click. So if I come here, notice the cursor changes to this solid cross, and then I just double click on that. And I'm done. So easy. So what we're saying here is that these 19 values are all 98.25. So if I want to add up all the values in that, class, well, since they're all the same, that's the approximation we're making. Since they're all the same, I just multiply 19 by 98.5 and I get the sum. I know that if I had the actual values, the result of adding up those individual values would be different. I would expect it to be different, but the hope is that it's not going to be too great a difference. So how can I get that product? Well, you just go equal, and watch how easy this is, man. This times in Excel is an asterisk. This. And we go down like that. All right. Of course, there is only one, so That's the sum there. I like to keep these things in the middle. I don't know if that's the best practice, but I like seeing like that. Anyway, and then we could drag or double click, right? So I'm dragging here and I get that sum. So now how can I get the mean? Well, I can get the mean by first getting the number of items. So I'll just put n here because I'm treating this as a population, and I'll maybe put this to the right, maybe like that. And here I'll get the sum. I'm getting the sum of these values here, right? So these are the counts. And let's put this in the middle. So that's how many values I have. Notice it's just the sum. So if I have an approximation of the sum of the values in each class, well, then adding these up will give me an approximation of the sum of all the values that were in the original data. An approximation. All right. And so I can get that sum by just doing this. We could group some of these steps into like one step, but I'm breaking it down so that you see this, right? So again, if you don't have to do it exactly the way I'm doing it here. There's a little thing here called AutoSum that you can't see. It's off the screen, but I'm sure you know what it is. It's the same function we use. And then we can get the mean. Just so that this looks a little bit better, I'll just drag this down here. And then I'll put the mean, let's say here. You may be wondering how I get these nice symbols here. There's a thing called equation editor. It's not on the screen, but if you go insert, and then to the right somewhere, there's a thing called equation. It's off the screen, right? So I do like this, and let me bring, I have this little thing here, right? And so I can just type. And so you need to know some of these little commands if you want to do this. That's mu, that's the Greek letter M, I believe, right? And it's a bit small, so I'll just make it a little bit bigger. For some strange reason, I can't just select 14. I have to select 16 and then it becomes 14. I don't know. I think that's a little glitch in this. I find Word has a lot of little bugs that people just leave them alone. So I'll just put this like this right here. All right. And then how do I get this mean? Well, it's equal to the estimated sum of all the values in the data set divided by the number of values we have. Notice how I'm working with ideas, man. The machine will do the calculating for you. And that gives me the mean. Now I need to find the variance. So how do we find the variance? Let's assume we had all the values in our data set. Well, then for each value, I find the square deviation. Remember, the deviation is simply the difference between a value in the data set and the mean of that data set. So for each value, I find the deviation and square it. And then I find the average of those square deviations, treating the data set as a population. To find the average of the square deviations, I would simply add them all up and divide by how many I have. In this case, 106. Remember, we're treating this data set as a population. Now, we don't have the actual values, so I'm just going to say that I'm going to make the approximation that for each class, well, the square deviation is the same because all the values in the class are the same. So every value in each class will have the same square deviation. So I simply need to find the square deviation of that value, which will be the midpoint of the class, and multiply it by the number of values I have in that class. If I do that for a particular class, I will, in effect, have the sum of the square deviations for that class. I then simply add them all up and divide by the number of elements that I have in all. So I don't have the actual values in my data set, but I have how many there are. There are 106. So we could do this all in one step. So let's just see how we can do that here. I just say equal, and it's the number of elements in a class times the square deviation. So that's the value that I'm assuming all the values are equal to, which is the midpoint in that particular class. So it's that value minus the mean. This is the mean here. Now, this needs to be an absolute reference, so look that up if you're not sure what I mean. When I'm going to drag this down to copy this equation, this expression in all of these cells, but as I do that, these will move down also. The values that the cell will be referencing will move down, but I don't want this one to move down. I want it to always be referencing this value. So that's what this is here. So you can just go to YouTube and type, absolute references in Excel or something like that. And then I'm going to square this. And I have it there. And then, of course, then I can just drag this down right to there. All right. And so again, so for example, what we're saying here is that the sum of the square deviations for this group is 22 times whatever this, the square of whatever deviation is associated with this value. So the deviation here would be what, 97.85 minus 98.168. Notice how this cell is referencing these cells as opposed to the one I originally used. But for the mean, it's still referencing the same value here. Okay, so that's how you do it all in one go. And I think in class, that's how I did it. But just to break this down and make it a bit more clear, let's find the deviations for each group, for each class. So I'll just come like that here and then say that's going to be what? Well, the midpoint of the class minus the mean. And that's the deviation. And of course, then I just find all of them. Again, I like to have them centered, so let's center them. That's not something, you have to do. And then I'm going to square these values here. So I'm just breaking this down. So maybe there's something of value educationally in doing that. So it's whatever this is squared, right? Again, I point out, I am not it's not about knowing formulas. Yes, you have to know these formulas, but it's more the idea that you have to be in control of. And then, yes, you have to know the formulas to give Excel, but then Excel is going to do your calculating, man. All right. I have sometimes, and I don't know what the heck did I do there. So the problem here is that I have this too close to this. I don't know why that's a problem, but let's move it up a bit. So again, these are little bugs that I find in like Microsoft products every now and again. So let's see if it works this time. And there we have it. Nice and neat. Now I'm seeing a little problem here though. And you see, I didn't put an absolute reference. So let's erase all these values here. And come back here. And so this F15 has to be an absolute reference. So I need a dollar sign before the F and a dollar sign before the 15. But a quick way to do this is to simply press F4. So you can't see what I'm pressing on my keyboard, but I just pressed F4 and then that happened. Notice I get my dollar signs where I need them. And now when I do that, everything looks nice again. So always just be aware of what you're doing. Now you should have some sense of like what you're expecting from your data. If you see something strange, it doesn't necessarily mean you made a mistake. In fact, your analysis of the data, one objective is to find the strange things. And but then you need to think about it. So if you have a value that turns out to be unexpectedly large, check to see if you made a mistake, or check the data, and then maybe there's something there that you would not have seen if you hadn't done your little analysis. Okay, so we have the square deviations, and then I want to add them up in each class. So we're assuming that every value in each class is the same, so the square deviation is going to be the same. So here now, all I have to say is the number of values in each class times, well, the square deviation for each value, in which case they're all the same. All right, so everybody has the same square deviation. I get that. And now we can find the variance. So the variance is simply the average of this. So it's this divided by the number of values we have. So let's get a nice little symbol here. Again, I'm going off the screen a bit. I'll just insert. You can just use symbol too. There's a symbol there's a symbol tab you can work with, but I prefer to simply work with this. I know the little codes. So for sigma, I need sigma, and then squared it because it's the and then let's make it a little bit bigger. So I come back home here, and like I said, I gotta go 16, and that way I'll get, oh, I got 14, I got 16. That is strange, see? Why didn't work like that for? Oh, I'm not finished with this though. And now we have it. And so it's 14, and I'll just put that here. And so let's get the sum here. Let's come out of this. Let's just get the sum here. You know, again, you could do this in different ways. As long as whatever work you do expresses the same idea, because we all have to be, the variance is one idea. There are not variations on that idea. But how that, the calculation, the actual steps, how you do it, there can be differences. And so then I just want the sum. You could go out to sum and do that, but I'm just doing it this way. Alright, so I have the sum of this. It looks reasonable. And then now this is going to be equal to whatever that sum is divided by the number of values we have. And there it is. We have our variance. And then now I want the standard deviation is just the square root of that. So let's go and let's see how the symbol works. I never use symbol, but symbol gives you this chart here. And the thing is with this, you kind of have to know like a different code, and I tend to know the other codes, but it's somewhere in here. See it right there. I think that's sigma. It looks a little bit different. Or is it the same thing? Let's just go and change the size of that to 14. It does look different. I don't like it. So let's go back and use the one given by the equation editor. So here I know that that's going to be sigma, right? So I know the little codes, and then I square it. And then I prefer this one. Let's see if I can get 14 again. See, it doesn't work this time. I don't know. There must be some little trick there. I know I put 16 and I get 14. So, oh, but why am I squaring it? I don't want the variance again. So let's just do this over. And let's make it a little bit bigger. Let's try 16 and see if it goes back to 14. Yes. And then this is just equal whatever square root. So there's a little function sqrt, and then I click this. So if I'm going too slow, you can just move ahead quickly in using the controls for this video. You can skip ahead. And there it is. There is our standard deviation. So we have the mean and we have the standard deviation. So I hope this helps. So bye for now.